Welcome to Let Me Fix This. Enjoy the video.
You start by identifying what acts on the object: gravity and aerodynamic drag. First, measure the mass m and the projected area a, and estimate the drag coefficient CD from shape. Once done, pick the drag model. Use linear drag for very low speeds or tiny particles, otherwise use quadratic drag for typical falling bodies. Next, record the fluid density rho. Then write Newton's second law, mdv/dt equals mg minus dv, so you can move directly into solving for steady speed. You now set net force equal to 0, so acceleration is 0. mg equals drag at terminal velocity. For linear drag, solve vt equals mg/b. But for most objects in air you use quadratic drag, so solve mg equals 1/2 rho a cd vt2 and rearrange to vt equals sqrt, 2 mg/ rho a cd. Make sure to estimate Reynolds number to justify quadratic drag. Once you decide the model, plug measured m, a, cd, and rho into the formula to get vt and m/s. You complete the calculation by inserting numbers and calculating vt. Double-check units so kg, m, and seconds cancel correctly. Once done, validate the result experimentally with a drop test over sufficient height or compare to published data for that shape. If results disagree significantly, make sure you use the correct CD and that measurements of area and mass are accurate. Also consider environmental causes. Wind, drafts, or unsteady turbulent flow can alter measured terminal speed. Adjust model or repeat measurements.
Thanks for watching. If you found this helpful, don't forget to like and subscribe.